I want you to close your eyes for a second. Just imagine standing on a landscape where the very concept of a sunrise simply does not exist.
Like completely absent.
Right. There is no east, no west, there's no twilight, no days, and definitely no nights. You are just engulfed in this endless, impenetrable void of pitch black space stretching out in every conceivable direction.
A very unsettling image.
It really is. And now, I want you to imagine the temperature. It is so unimaginably bone-chillingly cold that the very air you are used to breathing, I mean, the oxygen and nitrogen molecules themselves, has undergone a phase transition.
Yeah, people don't usually think about air freezing.
Exactly. The atmosphere hasn't just thinned out, it is completely condensed into a liquid rained down and frozen solid onto the terrain. You are standing on a literal glacier of frozen atmosphere, just staring up at a sky that is nothing but a graveyard of distant cold stars.
It sounds like something straight out of a high-concept cosmic horror film.
It does. It sounds exactly like sci-fi horror. But the reason we are looking at this today is that it is absolutely not science fiction. These are factual, physical entities.
Very real ones.
Astrophysicists refer to them as rogue planets or orphan planets. And to guide us through the sheer terror of this reality, we are pulling directly from a fascinating set of notes compiled by a channel called Ziko's Space Stories.
Which is an incredible resource, by the way.
Oh, it's fantastic. So our mission for this deep dive is to explore these cosmic ghosts. We really need to figure out the mechanics of how they become the invisible killers of the universe. And we're going to uncover why our seemingly peaceful, predictable solar system is actually resting on a knife's edge.
A very thin knife's edge.
Yeah. Okay, let's unpack this, because diving into these sources gave me a profound sense of vertigo about our place in the universe. I mean, it really messed with me.
I get that. It is a deeply unsettling reality to confront. You know, human beings are fundamentally conditioned to look up at the night sky and perceive order.
Right, we like patterns.
Exactly. We track constellations that have guided navigators for millennia. We understand that the planets in our solar system move in strict, predictable ellipses around our sun. It feels like this flawlessly calibrated clockwork mechanism governed by classical physics.
Like a giant cosmic watch.
Right. But the data presented in Ziko's notes completely shatters that illusion of safety, because the most staggering takeaway from our source material isn't just the mere existence of these rogue planets.
No, it's the numbers.
It is the sheer, overwhelming volume of them. The math suggests that for every single star you can see burning in our galaxy, there might be dozens of these wandering orphans.
Wait, dozens? For every single star?
Dozens. We are talking about billions, potentially trillions, of dark, lightless worlds just drifting silently through the interstellar void, completely untraceable.
That is, I mean, the scale of that is almost impossible to hold in your head. Dozens of rogue planets for every one star. It frames the galaxy less like an organized system of solar neighborhoods and more like a massive, crowded highway where billions of vehicles are hurtling around at top speed with their headlights completely turned off.
That's actually a very accurate way to picture it.
But before we get into the anxiety of these invisible objects creeping up on us, I need to understand the fundamental mechanics here. As a concerned skeptic, I kind of have to push back on the premise a little bit.
Sure, go ahead.
I've always understood that solar systems form from a single collapsing cloud of material, right? The star ignites in the center, the planets form from the leftover disk, and gravity locks everything in place.
That's the basic textbook model.
Yeah. And the sun's gravitational pull holds on to stuff like the Oort cloud, which is a literal light year away.
Sure.
So how does a fully formed planet ever generate enough energy to completely snap that gravitational tether and lose its sun in the first place?
Well, that is the perfect question to ask, because it addresses a major misconception about how solar systems are born. We tend to assume the formation is a gentle settling of dust.
Yeah, just spinning slowly into place.
But the reality is that the birth of a solar system is one of the most violent, chaotic, and overcrowded environments in the universe. Millions of years ago, long before Earth had a solid crust, let alone oceans, our early solar system was a highly volatile protoplanetary disk.
Okay, so a giant spinning disk of chaos.
Total chaos. And in the physics of a protoplanetary disk, mass is absolute power. As the massive gas giants, think of our own Jupiter and Saturn, began to accrete gas and rapidly increase in size, their gravitational influence expanded dramatically.
Makes sense. Bigger planet, more gravity.
Right. But they weren't just sitting in stable, peaceful orbits, they were migrating. Their immense gravity was actively churning the disk, completely warping the trajectories of everything around them.
Wait, so instead of just peacefully spinning in its lane, a young Jupiter was actively migrating through the solar system?
It was moving around significantly, yes.
That's crazy. So our own Jupiter was basically a planetary bully, just throwing its gravitational weight around and destabilizing all the smaller, rocky worlds trying to form.
Bully is a highly accurate way to frame it. In this incredibly dense environment, you have multiple developing planetary bodies crossing paths constantly.
Like a demolition derby.
Pretty much. And when a smaller planet, say, something the mass of Earth or Mars, happens to cross paths with a migrating gas giant like Jupiter, classical orbital mechanics take over in a truly violent fashion.
What happens? Does it just crash into it?
Usually no. The smaller planet doesn't just get bumped. It gets caught in the giant's incredibly steep gravity well.
Okay, let me try to visualize this. It sounds less like that clockwork model we talked about and more like a wildly violent cosmic game of billiards.
Oh, I like that comparison.
Yeah, so you've got the early solar system acting as the pool table, and these massive gas giants act as the cue ball. But it's not a direct impact, right? The gas giant comes barreling through, and if a smaller planet happens to be in the wrong place at the wrong time, it swings around the giant and gets violently slingshotted right off the table entirely.
What's fascinating here is how perfectly that billiards analogy translates to the actual physics of momentum transfer.
Oh, really?
Yeah. In astrophysics, this is known as a gravitational assist or a gravitational slingshot. We actually use this exact same mechanism to send human-made probes like Voyager out into deep space.
Right, flying them past Jupiter to get a speed boost.
Exactly. When the smaller planet falls into the gravitational pull of the gas giant, it accelerates wildly. Because of the specific angle of approach, it doesn't collide. Instead, it swings around the back of the giant.
And just steals its momentum.
Literally. In doing so, the smaller planet steals a fraction of the gas giant's orbital kinetic energy. The giant slows down by an imperceptible amount, but that stolen energy is transferred entirely to the smaller planet, hurling it outward at a terrifying velocity.
Wow.
A velocity so extreme that it drastically exceeds the escape velocity of the host star.
And escape velocity is the key there, isn't it? Once it hits that specific speed, the mathematical threshold is crossed. I mean, the sun's gravity might reach out for a light year, but the planet is moving way too fast to ever be pulled back. The door just locks behind it forever.
Precisely. The gravitational tether is officially severed. The smaller planet is forcefully evicted into interstellar space.
Just kicked out of the neighborhood.
Entirely. And from that exact second onward, it is condemned to be a cosmic orphan.
Yeah.
Think about the grim reality detailed in our source material. From the moment it crosses that threshold, it is eternally cut off from any source of radiant heat or light.
Because it's leaving the sun behind.
Yes. As it moves further and further from the sun, plunging into the void between star systems, any oceans it possessed would freeze into solid ice miles deep.
Just a completely dead, frozen rock.
Worse. The surface would plunge into absolute darkness, and eventually the temperature would drop so low that its very atmosphere would succumb to the cold, collapsing and freezing directly onto the crust.
Like the image we started with.
Exactly. It officially becomes a ghost, wandering the galaxy completely alone.
Man, it is a profoundly lonely image. Billions of dead, frozen worlds just flying blind through the interstellar medium. But this actually brings me to a massive logical friction point.
Okay, what is it?
If the math says there are dozens of these rogue planets for every single star, the obvious question for anyone listening to this deep dive is, why aren't we tracking them?
The tracking question.
Yeah, because we map out near-Earth asteroids all the time. We calculate the trajectories of comets decades in advance. If we know these rogue planets are out there, why can't we just point our deep space telescopes at the sky, chart their paths, and mathematically guarantee our own safety?
That is the exact question that keeps planetary defense researchers awake at night. And the answer is the terrifying truth of how human observation actually works.
Which is?
These planets are practically impossible to detect because of what they lack. You have to consider the fundamental mechanics of how a telescope functions. We observe objects in the cosmos through two primary methods.
Light and, well, more light.
Basically, either they emit their own light, like a star undergoing nuclear fusion, or they reflect the light of a nearby star, like how we see Mars or Jupiter reflecting our sun.
Right, because they are illuminated by something else.
Exactly. A rogue planet does neither. It has no internal fusion, so it doesn't glow, and it has no host star to illuminate it. It is an utterly black sphere, radiating almost zero heat, moving at tens of thousands of miles per hour through a background of equally black space.
Here's where it gets really interesting. And by interesting, I mean absolutely panic-inducing.
It is definitely panic-inducing.
Because you're saying they are perfectly camouflaged by the universe itself. The common analogy is looking for a black cat in a pitch-black room, but that doesn't even do it justice, does it?
Not even close.
It's more like trying to track a military stealth bomber at midnight with your radar completely turned off using only your naked eye. It emits no signal. It reflects no signal. So I have to push back again here. If they emit nothing and reflect nothing, how do astrophysicists confidently claim there are billions of them?
That's a very fair point to raise.
Right. Like, how do we know this ejection theory isn't just an elegant mathematical equation drawn on a chalkboard that doesn't actually exist in reality?
If we connect this to the bigger picture, the answer relies entirely on the genius of Albert Einstein and the fundamental nature of space-time.
Oh, we're bringing relativity into this.
We have to. Einstein's theory of general relativity proved that gravity isn't just a magnetic-like pull. Massive objects literally warp the physical fabric of space around them.
Like the classic bowling ball on a trampoline analogy.
Exactly. Imagine placing a heavy bowling ball on a trampoline. It creates a deep divot in the material. A rogue planet does the exact same thing to the fabric of space-time. So while our telescopes absolutely cannot see the dark planet itself, we can detect the visual distortion it causes when it moves.
Wait, let me make sure I'm following. So we are looking for the distortion of the space around the planet, not the planet itself.
Exactly. The sole detection method we possess for these invisible killers is an incredibly rare phenomenon called gravitational microlensing.
Gravitational microlensing. Okay, how does that work?
Here is the physical mechanism. An astronomer points a telescope at a very distant, very bright background star, perhaps thousands of light years away. Now, imagine that purely by chance, one of these lightless rogue planets drifts directly between our telescope and that distant star.
So it passes right in front of the light source?
Yes. And the rogue planet's intense gravity, that divot in space-time, acts precisely like a curved glass lens. Light for the background star naturally travels in a straight line, but as it hits the warped space around the rogue planet, the light beams are forced to curve around the planet.
Oh, wow.
They converge and focus directly toward our telescopes on Earth.
That is wild. So if we go back to the stealth bomber analogy, the stealth bomber flies in front of a distant streetlight, and instead of blocking the light, the bomber's gravity actually bends the light around itself, making the streetlight suddenly look way brighter for a few days, and then it dims back down once the bomber passes.
That is a brilliant way to conceptualize it. We never see the rogue planet. We simply see a distant star inexplicably magnify in brightness, then return to normal. That temporary spike in light is the gravitational fingerprint of a ghost.
But there has to be a catch, right? That sounds like finding a needle in a haystack of needles.
That is the catch. We only discover them by pure mathematical luck. If the rogue planet doesn't happen across the exact line of sight between Earth and a specific background star, we see absolutely nothing.
We just miss it entirely.
We are entirely blind to them. And because we have to rely on this 1 in a billion chance alignment to spot even a single one, statistical models indicate that the few we have found are just an incredibly tiny fraction of what is actually out there.
Which is terrifying.
Which leads to one of the most chilling bombshells in Ziko's notes. Statistically speaking, right now, as you're listening to this conversation, a rogue planet, the exact size and mass of Jupiter, could be lurking just outside the boundary of our solar system.
Seriously. Just right outside.
It could be slipping past the Oort cloud right now, hurtling toward us, and we would have absolutely zero warning until the gravitational effects began.
Okay, I need to pause and process that. A dark, Jupiter-sized wrecking ball, totally invisible, actively moving through our cosmic neighborhood. That is the ultimate suspense thriller right there.
It really is.
But let's play this out realistically, because I'm trying to keep my rational skeptic hat on here. Space is unfathomably, mind-bogglingly vast. The distances between our planets are so huge that you could fit every other planet in the solar system in the space between Earth and the Moon.
That's true. It's mostly empty space.
Right. So even if a rogue planet did wander into the solar system, a direct physical collision with Earth has to be statistically impossible, right? It would be like 2 grains of sand colliding in the middle of an empty football stadium. So what actually happens? Does it just quietly fly by and we survive?
You are correct that a direct physical impact is highly improbable. But the horrifying reality is that a direct impact is entirely unnecessary to trigger a planetary apocalypse.
Wait, really? It doesn't even have to hit us.
Not at all. Remember the cosmic billiards game that created the rogue planet in the first place? The exact same physics apply here. It all comes back to gravity.
Right, the slingshot effect.
Exactly. If a massive Jupiter-sized rogue planet simply passes through the inner solar system, it doesn't need to hit Earth. It doesn't even need to cross our immediate orbit. Its immense gravitational field would fundamentally disrupt the delicate orbital mechanics that keep our planet habitable.
So what does this all mean for us on the ground? Walk me through the timeline of this doomsday scenario. If the invisible killer misses us physically, how does it kill us?
It initiates a quiet, inescapable, and prolonged apocalypse. See, Earth currently resides in a highly specific, very stable orbit within the sun's habitable zone.
The Goldilocks zone.
Yes, that exact distance dictates our climate, our atmospheric pressure, and the existence of liquid water. If a massive gravitational wave from a passing rogue planet sweeps through our neighborhood, it would easily stretch or alter Earth's orbit. It would essentially tear us away from our stable path.
So no giant explosion.
No, there wouldn't be a sudden fiery Hollywood explosion. The crust wouldn't instantly shatter. Instead, our planet's trajectory would be elongated, or we could be ejected entirely. We would simply be pushed away from the sun, forcefully evicted into the freezing cosmic dark.
I'm visualizing the sequence of events laid out in the source material, and it's so much eerier than a sudden explosion. It would be an agonizingly slow realization.
A very slow fade to black.
Yeah, you would look up at the sky, and over a period of months, the sun would just begin to look a fraction smaller, a little bit dimmer, the daylight would lose its warmth, and the skies would begin to perpetually darken. Not from storm clouds, but because our actual life source is physically receding into the distance.
Exactly. And as the sun visually shrinks, the thermodynamics of our planet begin to break down. Without the constant influx of solar radiation to replenish the heat we naturally radiate into space, the global temperature would plummet precipitously.
It would get incredibly cold, incredibly fast.
Within a matter of weeks of leaving the habitable zone, the global climate collapses. The surface of our oceans would begin to rapidly freeze.
And as an audience that understands basic physics, we know that water freezes when it gets cold. That's obvious. But the specific sequence of the atmospheric collapse described in Ziko's notes is what truly terrifies me. It's not just a bad winter.
No, it is a total phase transition of the biosphere. Once the oceans are sealed under a thick layer of ice, the atmospheric cooling accelerates. First, all the water vapor in the atmosphere would crystallize, blanketing the ice in relentless, massive snowstorms.
Just a whiteout everywhere.
And then it gets worse. As the global temperature drops toward minus 100 degrees Fahrenheit, the carbon dioxide in the air would literally freeze out, falling from the sky as a continuous blizzard of dry ice.
Dry ice snow, that is insane.
And finally, as the planet approaches 300 to 350 degrees below zero, the actual nitrogen and oxygen in the air required for human survival would condense into a liquid state.
So it literally rains liquid air.
Yes. It would rain liquid oxygen onto the frozen surface, which would then freeze into solid atmospheric glaciers.
A literal downpour of liquid oxygen before the sky turns completely empty. That is an utterly haunting image. There are no alien invasions, no apocalyptic meteors striking a city, just the silent dimming of the daylight, followed by an eternal, perfectly preserved freeze.
Total silence.
Every city, every monument, every forest just sealed completely intact beneath miles of solid air in the absolute pitch black.
It brings this terrifying narrative full circle, doesn't it? If this gravitational disruption were to happen, Earth itself would be subjected to the exact same fate as the very thing that attacked it.
We would become a rogue planet.
We would join the billions of other cosmic ghosts, drifting aimlessly through the graveyard of interstellar space. We'd be completely invisible to any other civilization that might be looking through their own telescopes.
Yeah.
The source material uses a profound analogy, actually, referring to the cosmos as a dark forest. In a dark forest at night, you cannot see the massive predators moving silently between the trees. You only know they're there when you hear a twig snap right behind you.
And by the time you hear the snap, it's over.
Exactly. The twig snapping is the microlensing, the gravitational shift, and by then, it is already too late. Our solar system is just a tiny, fragile campfire burning in the middle of that dark forest. It provides us with a localized bubble of light and warmth, but it is surrounded on all sides by an endless expanse where silent, Invisible killers are constantly on the move.
You know, spending time with these sources really permanently shifts your perspective. I think it is human nature to wake up and completely take the sunrise for granted.
Oh, absolutely.
We step outside, we complain if the weather is a little too hot or a little too cold, all while being completely oblivious to the fact that our survival relies on a razor-thin margin of gravitational luck. The stable orbit we enjoy, the feeling of the sun warming your face, the simple fact that the oxygen you are breathing right now is in a gaseous state.
All of it is temporary, conditionally speaking.
Exactly. This deep dive really proves how incredibly fragile our peaceful existence truly is. We are floating entirely exposed in a cosmic shooting gallery, and the only reason we are here to talk about it is because we've managed to dodge the bullets for 4.5 billion years.
That underlying fragility is the ultimate inescapable takeaway here. We assume this stability is permanent simply because the entirety of human history is little more than a microscopic blip on the cosmic timeline.
Right, we just haven't been watching long enough.
We haven't been around nearly long enough to witness the true, sweeping chaos of the universe in action. But the laws of astrophysics are undeniable and unbiased. That violent billiards game that formed the early solar systems, it never actually ended.
It's still going on.
The game is still being played.
Yeah.
The pool table is just expanded to the size of the entire galaxy.
Man, it honestly makes you want to walk outside tomorrow morning and just stare up at the sun. Well, obviously not directly at it, but just take a moment to deeply appreciate that it's there, to physically anchor yourself to the light.
It really does.
Because the alternative scenario we've explored today, I mean, this dark, frozen, wandering through the endless void, it has to be the most profoundly lonely fate I can possibly imagine for a world.
It is the definition of profound isolation.
Yeah.
But, analyzing the physics of that isolation actually presents one final, incredibly haunting possibility. Just a lingering thought for you to consider.
Okay, lay it on me.
We talked about how as Earth is ejected, the oceans would freeze from the top down. Well, because water expands when it freezes, ice floats. That creates a massive, miles-thick insulating lid over the oceans.
Oh, right. The ice protects the water underneath.
Exactly. So while the surface is hundreds of degrees below zero, the deep ocean floor is still being heated by the planet's internal geothermal vents. If Earth's fate in this scenario is to become a frozen orphan, preserving a liquid ocean deep beneath the ice.
Wait, are you saying?
Is it mathematically possible that somewhere out there, hidden in the dark source of space right now, deep beneath the icy crusts of those billions of drifting rogue planets, lie the warm, pitch-black oceans of other worlds? Worlds that were once just like ours, secretly harboring life in the dark.
Wow, just millions of worlds that had their own campfires, right up until the exact moment something invisible in the dark forest snuffed them out, leaving the survivors trapped under the ice.
It's a very real possibility.
That is a thought that is going to stay with me for a very long time. Well, thank you for joining us on this incredibly chilling cosmic journey today. Keep looking up, keep questioning the mechanics of the universe around you, and as you go about your day, hold on tight to our stable sun. It might be the only thing keeping the dark forest at bay.